Welcome to the Secret Underground Laboratory Recovery and Salvage, where rude mechanicals do magic. Hello, I'm Bronze Age, Director of the Secret Underground Laboratory Recovery and Salvage. Today we're at the lamp bench with a fairly unusual kind of light fixture. What's unusual about it is, except for sockets and the wire, there's no hardware whatsoever in this entire light fixture. This is a type of lighting known as high skill, low tech. Except for the wires and the sockets, this piece is made entirely of galvanized steel sheet metal. And what you have to imagine is that you're someplace, say Mexico. I think this is probably where this is from. You've got a sheet metal shop where you can make ducts for air conditioning, heating, whatever they need in Mexico. And somebody comes along and says, can you make me some kind of chandelier? And sure, you make one of these. He says, can you make me 1,000 of them? And so with your sheet metal shop and the sheet metal you have there, you're able to make a light that can be exported. You may not know a lot about making chandeliers, but you do know sheet metal. Candle cup has this little rolled edge here, which makes it nice and smooth. Nothing to cut your customer up. The bow biche is a piece of round sheet metal with this pie crust edging milled into it with a little machine. The arms, another piece of flat sheet metal with the edges rolled over, and that gives it the strength so that it won't sag or bend. And the body here is two sheet metal cones. They're joined together in the middle. Now, when I said it was put together without any hardware, what I'm talking about is the usual pipe, nut, spacers, and stuff like that we see in regular chandeliers. This piece is held together only with solder. Solder is the lowest form of welding, just below JB weld. Solder is a mixture of various metals that have a very low melting point. Lead and tin used to be the most common kind of solder. They've pretty much tried to take the lead out of it these days. But the process is, you get your base metal, your sheet metal here, very clean. Then you heat this up just hot enough that it'll melt the solder, but not hot enough to melt the steel. And then you run it underneath here. It wicks up all these surfaces, and then when the solder cools, it's stuck together. Pretty good, reliable kind of connection. Not the strongest thing in the world, but anything that could break the solder joints, also likely just to bend anything. This goes all the way down to the arms, which are soldered to these cones. And the question becomes, how do you get inside this thing? This piece here is crimped over the other one, and what I'm going to have to do is go around and slightly bend it outward, because there is one spot somewhere around here where they've got a drop of solder on it to seal it up. At least I hope it's just one spot. It appears the solder joint's right there, and so I apply solder's natural enemy, fire. And this is one of those times where having free hands would be very useful. During all that handling, this piece on top came off, but that's not going to be an issue because we will be putting it back together with hardware. With any project that requires re-engineering the basic design, the engineering needs to come first. So in this case, what I'm going to do is run a pipe from the bottom, and it'll be held up here at the top, clamping these two cones together. And of course, I've got to have some way to anchor it down there in the bottom. The hardware solution is two short pieces of pipe, and these pieces are hardware called hickeys. And all threaded connections in the lab are sealed with thread lock, this blue stuff, so that when I tighten it down with just a little bit of torque, that will, once that stuff sets up, this will not come loose during any sort of normal operation. The last step, right here where the wire is going to come out, I've got a cord protector. And I'm going to set this down in the bottom with fiberglass resin jelly auto body repair compound. This is a two-part mix. A little bit of hardener will go a long way. Very similar to mixing epoxy. When thoroughly mixed, and your working time on this 10-15 minutes. And this is actually a fiberglass compound. I mean, it's called fiberglass compound because it's got little pieces of fiberglass chopped up inside the resin. And once it sets up, it's incredibly strong, but it can also be sanded, carved, mixed up. I'll just stick this down in here, put the top on it, let this sit about a half an hour, and we'll be ready to go back to work. Now this is set up nice, it's good and strong. I don't think that's ever going to come loose. I put this cord protector here because that's where the cord's going to come out, and I don't want wires rubbing against any sort of metal edge. And that leads me to here. These holes are punched, which has left a jagged edge on the inside. So what I'm going to have to do is fix these so that I can put a cord protector in them as well. And that brings us to the Packer 12-speed precision drill press. I'm going to use this little small cord protector here. It just snaps into a 5/16 hole. And these holes are a little too small. Plus I have a problem with drilling out sheet metal, is that it tends to grab on the bit and distort and bend things up. I don't want to do that. Plus I don't want to get this hole any closer to the edge here. So I want to make sure that the hole stays up on the top side here, which of course calls for a jig. I've got this piece of wood here and one on top with a slight curve that matches the curve of the cone. Put this like this, clamp it down, and now the drill bit is going to make the hole in the perfect place, and there's no way that this sheet metal can bend, warp, or distort when the bit goes through it. We are turning at 1000 RPM. We'll do this 7 more times and move on. We have one more issue in cord protection, which is this hole here in the bobiche, which of course calls for another jig. Now this may look like overkill, and it probably is, but this bobiche is connected to the arm just with a solder joint. So when this drill bit goes in here, I don't want there to be any twisting motion between the arm and the bobiche. This clamps the bobiche down between here and here, so it can't move, and then it can't transfer any stress into the arm, which if that came off, that would just make a lot more work for the job. So this kind of a setup for what is basically a 1-second operation is actually worth the time. I'm going to be rewiring with a silver lamp cord, which is really just transparent insulation with a tin-coated copper wire on the inside. Now, lamp cord sold in the United States and North America, one side has smooth insulation, one side has ridges. And when you're making the main connection inside the body, all your smooth wires go to your main smooth wire, and all your ridge wires go to your main ridge wires. And on this particular kind of wire with the silver, it's basically impossible to see that ridge. You've got to feel it every time. So to make it just a little easier, when I'm going to be peeling this back and soldering it together, I like to put a black stripe on the smooth side, because eventually when all of this gets to the wiring at the house, you're usually going to see a black wire and a white wire. And the smooth wire on any kind of lamp or lighting corresponds to the black wire at the wall. Now I have all the wires peeled back and I'm ready to solder them. Now, even though I painted the smooth wires black, before you do this, it's a really good idea to count the individual wires in each bundle. Because when you've got 9, which what this has, 8 for the arms and then the trunk wire, it's really easy to get one on the wrong side. And if you discover that after you solder it, well, that just makes a lot of work for everybody. Now, I'm not happy with this one. I'm going to heat it up and let it soak just a little bit more. I want that solder to go all the way through to the other side, which might take just a little bit of time. Catch both of these. All connections in the lab are soldered. We never rely on wire nuts or just twisting the wire. I'll let this cool off a little bit and make sure I don't have any sharp pieces poking out, because we're going to cover this with shrink tubing, which is a peculiar kind of plastic which will shrink. Much better than tape. And just for a little lab overkill, fold it back, slide another piece over the end, and that doubles the amount of insulation over the actual end of the junction. Now I can feed all these wires through these little bushings. With that done, the trunk wire goes up the pipe. And through the top up here. And I'm able to work this down around that mass of spaghetti. Now at the top, little thread sealer and a nut. And this is a case where the thread sealer is really important, because this thing is made of sheet metal, and this nut has more than enough strength to basically crush this whole thing. If I were to tighten it down, it would just keep going. It would squash this thing. So the thread sealer, once it sets up, will keep this nut nice and tight. And this cord protector will keep the cord from getting slashed up. Alright, it's 24 hours into the future and I'm cleaning off the bench for the next project. And I noticed this. Which is why I make such a big deal about cord protection. When you're dealing with artist-made, or in this case, artisan-made lighting, this is where your problem is usually going to crop up. And that is how you're holding the socket to the actual lamp. In this case, all they've got is a cardboard candle cover, and they've got it slipped down inside this little lightweight sheet metal cup. ideally, there would be a short piece of pipe here that the socket could screw down to, put it in place with a lock nut, and everything would be fine. But there's no practical way to attach this short piece of pipe to this sheet metal. I could epoxy something in, or even possibly solder something in, but we're talking about epoxy not working very well and the solder making this job a lot more expensive than it has to be. My solution, which is just one step above the candle cover, but a little better, is to take a little rubber piece here called a bottle adapter, made for going in the neck of a bottle if you want to make a lamp into it, which I'm sure everybody wants to do that, and then fit it to this candle cup. And the problem is, not all the candle cups are the size, so I'll be trimming these down to make them fit. Threaded lamp pipe comes in lengths up to 36 inches, and the shorter it is, the more it costs per inch. So I cut my own. I'm using a shop-made tool, which started out as one of these brass couplers with the pipe threads on the inside. Split it in half, and then I can clamp this in the vise without crushing the pipe or damaging the threads. And once I've got all my pieces cut, I've got to clean up these ragged edges left by the hacksaw. And that calls for another shop-made tool, which is a pair of vice grips, which has a coupler like that that's been brazed to the jaws. And it allows me to hold this thing so I can pull it back and forth like that until the tip is smooth, and then I roll it at an angle, and that will take care of any of the little jagged pieces. And I've got a tapered countersink here, which will deburr it, and I've got a wire that's pretty safe for the, pipe that's pretty safe for the wire to go through. Having a tool that will hold a little stubby piece of pipe comes in very handy. I can clamp it here in the vise and assemble the sockets with very little effort. I'm trying to hold on to that pipe while you're pushing the rubber bottle adapter down on it. It's no fun at all. Being able to keep that piece in place, that makes short work. Each of these has to be hand fitted into the cup because they're all different sizes. Now with all the sockets installed, the difference between the wire with the smooth insulation and the ridged insulation is important again. I'm going to strip both pieces back about half an inch or so. Now this kind of wire is made of many strands, very tiny wires all bundled together, and that is why lamp cord is so flexible. These small wires can move against each other and they won't take a kink. But the National Electrical Code says that you can't put stranded wires under a screw terminal. So the solution to that is to turn all those many wires into one wire. And a little drop of solder is all it takes. Usually try not to put too much on it because I want it to curl around that screw without any trouble. Like that. Next up, lamp sockets sold in North America have one brass screw, one silver screw. The wire that has the ridged insulation always goes around the silver screw. This screw actually goes to the shell in the bulb. And it's out of sight back here, but I'm putting the smooth wire around the brass colored screw. It goes to the center terminal. Now what this means in the real world is if you were to come across a light fixture that didn't have a light socket in it, a light bulb in the socket, which it could be chandelier, sconce, or most likely a table lamp, and it was plugged in, and you touch the shell looking for the light switch, you're not going to get shocked. You would have to push your finger all the way down to the inside to touch that center terminal where the smooth wire is connected. Then you'd get shocked. How often that happens in real life, I don't know. But that's the way North America dealt with it. In Europe, they made totally different kinds of sockets. Plastic with no metal showing on the outside. And the North American way of dealing with this dire problem of people sticking their fingers in light sockets was basically a simple change in the electrical code and then turning the plugs at the wall so that they only go in one way, so these wires stay straight all the way up to the socket. And that's the way we dealt with it. What I like about this chandelier is its real simplicity. The maker did not try to imitate some sort of antique French piece or Spanish Mediterranean, that sort of thing. He simply took the materials and the machinery that he had, and he made a functional and somewhat attractive ceiling fixture. And for that, he can be applauded. And today what we did was simply bring it into the 21st century so that it meets all the current codes. And even though by itself it wasn't particularly dangerous the way he made it. So that's it for this video. Appreciate you sitting through the video about the low-tech, high-skill chandelier. We really appreciate a thumbs up. Subscribe if you haven't already. And I hope to see you again next week. Thanks for watching.